This is the Calculus Pre-Lecture Series. I'm Brandon Ashley, and this video is on power series. So we define a power series to be any series of the form sum from n equals 0 to infinity of c sub n times x minus a to the n, where this a is some real number, and we usually call it the center of the power series. And the c sub n can be any function of n. And if we want to know some examples of these power series, we can just start filling in some values for c sub n and for a. So one we'll see is going to be the sum from n equals 0 to infinity of x to the n, where here our c sub n is just equal to 1 for all values of n, and a is equal to 0 because it didn't show up. And we could also come up with other series, so we could have n equals 0 to infinity of x minus 1 to the n over n factorial, where our c sub n would be equal to 1 over n factorial, and a is equal to 1. Or we could have sum from n equals 0 to infinity of x plus 2 to the n times square root of n, where c sub n is just the square root of n, and a this time is equal to negative 2, because we do minus negative 2, it gives positive 2. So these are all examples of power series, and we want to kind of look at this first one a little closer. So if we consider the series n equals 0 to infinity of x to the n, we can start writing out the terms as x to the 0 power, which is just 1, plus x to the first, which is x, plus x squared, plus x cubed, plus x to the fourth, and so on. But we've seen series that look like this before, and we called them geometric series. So recall geometric series which were just series of the form sum from n equals 0 to infinity. I'll write b times r to the n. So this is what our geometric series look like. And we really like geometric series because we know when they'll converge and exactly what they'll converge to if they do converge. So this geometric series was equal to b over 1 minus r if the absolute value of r was less than 1. And it turns out that our power series up here, so the series sum from n equals 0 to infinity of x to the n, is geometric. It's a geometric series, and it's geometric with b, the coefficient out in front, equal to 1, and r is equal to x. And this is great because that means we can write the sum from n equals 0 to infinity of x to the n, our power series, is going to converge to, b was 1, so I have 1 over 1 minus, our r is x, so I get x. when the absolute value of x is less than 1, or sometimes we just write that x is between -1 and 1. So we see that sometimes you can have power series here. This is just a power series. Sometimes these power series can be represented with a function.